Hey everybody, this is just a quick little help video to walk you through this phase diagram handout that I gave you. And when you printed this out, hopefully you noticed that the answers were actually uh, part of the file. So you already have answers, but I want to make sure you understand where the answers came from here. So a couple of key points here. We remember that there's a general shape to these. There's sort of a curvy line that always separates solids from gases, and solids are always in this general area. Gases are always sort of in this bottom right corner. And then there's always sort of this wedge-shaped piece where the liquids live. And we remember that there's two important points. There's this point right here, which is the point where at this particular pressure and this particular temperature, all three phases can exist at the same time. So since it's three phases, this is labeled the triple point. And then we have another place on this graph that I want you to be familiar with here, and this is the critical point. And it's important to note that if I am above the critical pressure and temperature, and I'm up here in this area, I am what we call a supercritical fluid. And that was the cool little video that I had for you guys on Tuesday, where you had, just this thing that sort of a liquid, sort of a gas, sort of neither, sort of both, has some very interesting properties. So what is the critical temperature of compound X? We know that this is the critical point, so the critical temperature would be somewhere on the order of, and if I were to look at my answers here, I think I put about 770 degrees Celsius. All right, second question. I'm gonna try and keep the graph relatively handy as we look at these questions. If we had a bottle containing compound X in your closet, what phase would it be in? Well, we know that our pressure is 1 atmosphere. Now let's look at 1 atmosphere is lower than I even have on this graph right here. It only goes down to 10 atmospheres. So there should be no doubt that I would be in this gaseous area of my diagram. So if I had a bottle of this in my closet, it would be a gas. Number 3, at what temperature and pressure would all three phases coexist? That's basically asking you for the temperature and pressure associated with the triple point. And so as I look at that, I'd say that's about 50 ATMs, 50 atmospheres. And we've got about, I'd say it's about 350 degrees Celsius. All right. If I have a bottle of compound X at a pressure of 45 ATMs and a temperature of 100 degrees Celsius. So I'm starting out at 100 degrees Celsius, which is right here, and I'm at 45 ATMs, and I heat it all the way up to 400 degrees Celsius, right? Doesn't say anything about changing the pressure, so I gotta stay at 45 all the way across. As I go from 100 to 400, I'm going straight from a solid state into a gaseous state. And so that is called sublimation. Sublimation. And I need to scoot up because I know that I am writing off of the screen for you guys. Sorry about that. So we got sublimation there. All right, I'm gonna go back to the graph and then pull this up for the question writing. Why can't compound X be boiled at 200 degrees Celsius? So at 200 degrees Celsius, let's see where we are. So for boiling, boiling is the process of going from a liquid to a gas. Well, there's no way at 200 degrees Celsius I can ever go from a liquid to a gas because I'm never a liquid at 200 degrees Celsius. So reason here, why can't it be boiled? All right, liquid state, not possible at 200 degrees Celsius. All right. You would have to be above 350 degrees because as we look at our diagram, above 350 degrees, that's where I can, depending on my pressure, that's where I can see my liquid state happening. All right, and almost done. If I wanted to, could I drink compound X? Well, in order to drink it, it would be a liquid. And in order for me to drink it as a liquid, it would have to be above 350 degrees Celsius and above 50 atmospheres. And so this would be a very unsafe drink because it is hot, hot, hot. So hopefully that makes sense and you get a little bit more comfort with phase diagrams out of this. And that's all I've got for you here. And I'll see you guys soon. Okay, take care. Bye-bye.